Assalamualaikum warahmatullahi wabarakatuh. The Excellencies, the Honorable Rector of Lambung Mangkurat University, the Honorable of the Director of Center of Innovation, Technology, Commercialization, Management, Forest and Wetland, Lambung Mangkurat University, PHLB ULM, the Honorable of the speakers who join us today, the members and organizing team, committees, distinguished guests, participants, colleagues and students, ladies and gentlemen. A very good morning to each of you. We are delighted to welcome you to the Webinar International Conference, Sustainability of Wetlands Series 1, which is provided by the Center of Innovation, Technology, Commercialization, Management, Forest and Wetland, Lambung Mangkurat University. Before we start, I would like to share you all the conference rule of our conference today. Please share screen, the operator. We're waiting for the operator to share screen. Thank you. All right. Before we start, this is the rule of the conference for today. Please, the next slide. So, theme of our conference, yes. Thank you. All right. So we have the rule for as audience. So please put your name, underscore, and institution by right-click on your profile pictures on the Zoom monitor. This is important for us if you have any questions. And then once you right-click of your profile picture, please select your name and write your name underscore institution. For instance, Mutia underscore PHLB ULM. The next one, Zoom meeting already accessed for all of us. And if you have any other guests, please join us. And also during the conference, please turn on your microphone, make it mute during the conference. The microphone can only be turned on if requested by the moderator. If you have any question, you could ask into a chat room, and then the operator will link your question to the moderator, and then the moderator will select the question and ask them for the speakers. And you could also ask the question, use English or Bahasa Indonesia.
Halo.
Moderatornya keluar, Pak. Atau keluar moderatornya, kita tunggu dulu, Pak.
Halo. Ya, halo nih. Bumut kita keluar kah? Ya, ya. Sedia dia anu, Mak. Enggak cukup lah. Ya, ya, ya. Okay, the audience is, I think, they have a problem with the connection. So hopefully, Mrs. Mutia can be back in this Zoom. Kalau dia mau masuk. Iya, dia semua masuk juga sudah. Mau masuk, dia mau masuk sudah. Sudah saya telepon.
Ladies and gentlemen, I would say very sorry for this morning about the problem of internet connection. So go to the first agenda today, and the welcome speech will be delivered by the director of the PHLB of ULM. Please, the floor for Prof. Yudi. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi. Thank you for the MC who has given us the opportunity to give a speech on these occasions. So the Honorable Bapak Dr. Suryadi from IHA Delft, Netherlands. Good morning, Pak Suryadi.
Yeah, good morning. Thank you very much, Pak.
Yeah. The Honorable Mr. Dr. Insinyur Peter van der Meer. This is my college from Panha. And we can meet today in good health, even though during the COVID-19 epidemic without obstacle. Secondly, my salawat and salam always be given to our Prophet Muhammad SAW, who has guided us from the darkness to the brightness. Before we start the speech for today, I would like to give you pantun. Wah. I think the people from Sumatra is very common, yeah, with the pantun, ya. Ke pasar beli semangka, semangka dipetik di dekat hutan. Hai, apa kabar semuanya? Selamat bertemu di konferensi hari ini saya ucapkan. Melihat ke atas, indahnya awan. Di atas awan ada matahari. Selamat bertemu para hadirin. Semoga tetap betah sampai selesai. So I would like to introduce myself. I'm Yudi Firmanul Arifin. I am also the director of PHLB ULM, and also I am vice rector for planning, cooperation, and public relations at Lambung Mangkurat University. Would like to convey my happiness and pride to be able to speak at international conference on sustainable of wetlands today. This is the first international conference for the theme of wetlands with the sub-themes of the biodiversity, commercialization, and sustainability of wetlands, organized by PHLB ULM. I would like to convey several things related to the organization of PHLB ULM. PHLB ULM is a center of excellence for innovation, technology, and commercialization and management, forests and wetlands. The Center of Excellence was formerly known as the Research Consortium for Sustainable Tropical Forest Management, which was established 2012 and has been designated as Center of Excellence in Science and Technology by the Ministry of Research, Technology, and Higher Education in 2015. PHLB ULM has a research focus on non-timber forest product or from the upstream to the downstream. A lot of research, publication, technology transfer, and non-timber forest products are produced by this Center of Excellence. The Center of Excellence also held 4 series webinars on medicinal plants in this 2020. Apart of the concentrating of the non-timber forest products, we also carry out various research activities related to wetlands, because this is related to the vision of Lambung Mangkurat University. I would like to say that the vision of Lambung Mangkurat University is to become a leading university and competitive in the field of wetland environment. The several activities were carried out to realize the vision, one of which was organizing webinar, as this is like today. In addition, in 2020, ULM provides research funding support for all ULM lectures. This is the strategy of the ULM to make some research, especially for the wetland management with various perspectives. In the 2020, ULM give funding for 355 proposals on wetland. It means that in this year, we will produce about 355 publications in 2020. ULM also collaborates with the various stakeholders, both national and also international. One of the ULM partners for wetland development is the Peat Restoration Agency, or BRG. BRG is the Peat Restoration Agency, and we have also joint research since 2017 until 2019. In this collaboration, we have also produced some reports and also publications about development of peatlands. This is very important, I think, the result of our research collaboration with the BRG. And international collaboration and cooperation are also carried out with the various universities abroad. One of which is Panhal University of Applied Science. This is a university partners of the ULM, and we collaborate, has been implemented since 2015. And thank you for Peter van der Meer. He is a very valuable person in this collaboration, and that until now, this collaboration still continues. The collaboration that have been carried out are research collaboration, and also we have other researcher exchange and also student exchange, and holding international seminar like today. And this is the newest partner for cooperation in wetland development is IHE Delft. Yeah. This year we have a collaboration with Delft to make TMT. TMT is tailor-made training on water and soil management on peatland. And we which is planned to be carried out from 21 until 23 September this year. And I think we will continue again 2021 for the practice, because for the practice for today, for this year, this is impossible because the COVID pandemic. And we are very grateful by Dr. Suryadi, who has a resource person at today's conference. He was also one of initiators of the collaboration between IHA Delft and Lambung Mangkurat University. And we are grateful and to receive funding from the Nuffic Netherlands. Thank you for Suryadi for this initiator for the collaboration.
Thank you.
We continue to carry out various collaboration also for development, the research related to wetland. Could be would like to realize the vision of the University of Lambung Mangkurat in 2027. We will be a center of excellence for wetland, and at the Asian level can be realized. I also inform you that this webinar on wetland, we will continue for the second series. This is the first series. The first series, the theme of this series is sustainable of wetland and biodiversity, commercialization and sustainability of wetland. And the for series 2 held on Wednesday, September 23, 2020. Then the title is the development of wetland biomaterials. And the series number 3 we held on the Wednesday, September 30, 2020, and the title of potential of wetland vegetation as functional food ingredients. And the last is the fourth series will be held on Wednesday, October 7, 2020, and the title Business Development Opportunities Based on Potential Local Plant Product of Wetlands. It means that every Wednesday we will have the webinar, yeah, and different title. And I'm updated with this webinar series we will discuss in detail various development problems in the wetland and to look for possible solution from various perspectives in the field of science. That is my welcome. Thank you for participating in this webinar, and I hope that today participants can also participate in the next webinar. Okay, I would like to open this seminar because our rector cannot cannot join with us today, and I representative by rector to open this webinar. So by saying Bismillahirrahmanirrahim, today's international conference is officially open. Thank you very much. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Prof. Yudi Firmanul Arifin, for giving the welcome speech and as well as the opening speech for our conference for today. That is true that because there is inauguration of 3 professors in Lambung Mangkurat University at the same time for today. So director will not be able to join us. All right, that's okay. So we are moving to the next agenda where there are 4 keynote speakers for us. That is very important. People give us some sharing some experience and others for us for today. So let me introduce our first keynote speakers. which is the director of PHLB itself, of ULM. And also Professor Dr. Yudi Firmanul Arifin is also the professor of forest ecology faculty of forestry, Lambung Mangkurat University. His CV, so Professor Dr. Yudi Firmanul Arifin was born in Banjarmasin, 1967. Now he is a Vice Rector of Planning, Cooperation and Public Relation of Lambung Mangkurat University. He is also a Director of Center of Innovation, Technology, Commercialization, Management Forests. He is a Professor of Forest Ecology. Now he is a lecturer in Faculty of Forestry in Lambung Mangkurat University. Professor Yudi Firmanul Arifin was studied in long time in Germany. So he did his bachelor degree in Lambung Mangkurat University and did a master and doctoral degree in Georg August Universität Göttingen, Germany. He has a lot of experience in doing research and also doing management in our university. So he's the one who is very famous in our university. Now, let me give a time for experience for us. So Professor Yudi Firmanul Arifin, the floor is yours, please.
Okay, thank you, the moderator. Ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. Today, I would like to speak about the effects of degradations and also potential of peatland resources. And I try to explain the case study in Kalimantan, especially. Yeah, because this is part of our research joined with our students in Kalimantan, especially concerned with the peatland area. So I'm Yudi Firmanul Arifin. I'm a professor of forest ecology, Lambung Mangkurat University, and also I'm director of Center of Excellence for Innovation, Technology, Commercialization, and Management, Forest and Wetland. So the first presentation, I would like to introduce a little bit about the vision of our university, Lambung Mangkurat University, being the leading university and high competitiveness in the field of wetland environment. So for this vision, to realize this vision, we try to make some research, especially for wetlands. And also we try to collaborate and also cooperation with other institutions, national and also international in the world. So many in the universities, we try to collaborate to make research together, especially for wetland environment case. So I think all of you know that this is the definition of the Ramsar Conventions, that wetlands are defined as the areas of marsh, fen, peatland or water, whether natural or artificial, permanent or temporary, with water that is static or flowing, fresh, brackish or salt, including areas of marine water, the depth of which at all tide does not exceed 6 meters. This is the definition according to Ramsar Convention. So the 5 major wetland types are generally recognized. The first is marine coastal wetland including coastal lagoons, rocky shores, seagrass bed, and coral reefs. Estuarine also, yeah, including deltas, tidal marsh, and also mud flats and mangrove swamps. Lacustrine wetland associated with the lakes, riverine wetland along river and streams. Palustrine, yeah, meaning marshy swamp and bogs. So this is the major wetland types and generally recognized by the people. So, but today I would like to concern with the peatlands. This is the one type of the wetland. So, peatlands, yeah, in Indonesia, yeah, the large area of Indonesian peatland, we have about 26 million hectares spread over Sumatra, about 7.2 million hectares in Kalimantan, or about 35%. Kalimantan is 5.8 million hectares, or about 22%. And Papua, this is the largest of the peatlands, is 10.9 million hectares, or 42%, and the rest in the other islands. So the other data, I have also the data that Indonesia, we have 22.5 million hectares. This is the 5 big countries has the peatland areas. So it means that Indonesia is very big island, very big, probably largest island, very largest peatland areas in the world. So this is the major agroclimatic condition in, I would like to a little bit focus on Indonesia, because Indonesia is one unit trophic, and normally we have only 2 seasons, yeah, dry season and wet season, and sometimes you know that the evaporation is very high. It means that if the area quite often, sometimes this is a little bit problem because the evaporation is very high and very easy to dry for the peat area, and sometimes we have the problem if the evaporation is very high. So this is the condition, spatial information of land use in Kalimantan. You know that the area was some of the area in Kalimantan is quite often, yeah, because and I think the rest of the forest is only 50%, and the other is quite open, yeah, and also the area of the peat swamp is quite open, and this is very dangerous. Sometimes if the dry season, yeah, we have a problem with the hedge office, we have a problem with the fire. So this is the deforestation in Kalimantan since 1950 until 2010, and also projection in 2020. You can see that the area of the forest decreased every year, every 5 years, and until 2020, like now that it is could be the forest area cover only 50% of the area forest. There's some problems in the peatland areas is large area of peat forests in Indonesia are drained or clear for cultivation. Sometimes we have a problem with the development of the palm oil, for example, because they need the big area, I mean the large area too often. And sometimes this is also the dangers for the peatland areas, and also for other agriculture crops. So has caused several important problems. We have also problem in you know that we have a problem with the climate change, hedge subsidence, biodiversity loss, And also, this is the challenge for us, more sustainable system reducing the trade-off effect between economic and environmental benefits. So this is sometimes the people call the wetlands is the same with wasteland. Why this wasteland? Because, you know, sometimes the people said the wetland is unproductive land because every year we have the problem, for example, especially in Sumatra and Kalimantan, we have a problem with fire. And also wetland normally are like marginal lands or unproductive land. And sometimes the people wetland as the same wasteland. And wasteland, this is unvaluable land. How can we make the wasteland become valuable land? This is the challenge for us. So, you know, this is the problem. Our peatland in Kalimantan, yeah, we have so many hotspot, yeah, especially in dry season. So you can see that this is from the satellite, you can see that the distribution of hotspot in Kalimantan, especially in the dry season. So some of the big question often occur in society. What does the question? Why are peatlands unproductive? Do peatlands have economic value? This is also, what is the economic value of peatlands? How can we increase peatland productivity? That is our challenge. So this is the distribution of peatland. I would like to describe a little bit about the effect of the clearing of the peatland. This is the case in the Central Kalimantan, for example. 1 million, I think all of the people in Indonesia now remind that about the 1 million hectare peat soil development project in Kalimantan. So until now we have the area is quite often and have the problem, especially in dry season. Yeah, the fire rate also very high, and also the subsidence, and also, you know, we have a problem with the fire. Most of the plants near with the river also die, especially because the fire rate is very, very high and very acid. So this is the XPLG project in Central Kalimantan. You can see that the area is quite often, yeah, evaporation is very high, and also very acid, yeah, very acid. I think the pH is about 4 until 5, until below than 5. So this is our research together with my students. I would like to compare that the location of Tuanan. Tuanan is natural peat forest in the area of XPLG, and this is still natural. And XPLG location with peat, and also we have XPLG location with peat thickness is about 3 meters deep. This means that this is two different areas. This is the area still natural, and this is have already open. So you can see that the picture, this is quite often. This is quite clear that especially in the open area, sometimes we have a problem with the fire. So peatlands are very fragile ecosystem. If you say the book and you say you can read in the journal, sometimes the people said peatlands are very fragile ecosystem, because the soil is inherently acidic and poor in nutrient and also mineral needed by plants. It means that if the area clear, so very not so easy to be back like naturally. So peatland also have important hydrologic control of the watershed areas and the environment, because you know that their ability to absorb the water is about 30 times. This is very important. And also they can also store very lot of the carbon. Yeah, this is the rule of the peatland. So this is the different condition, both Tuanan is natural, I mentioned that before, and XPLG. So in the location of Tuanan, peat thickness 3 meters. So the pH is about 4 until 4.4, and the soil texture is dominant by peat. And information that especially in Tuanan natural condition, this is a little burn, but XPLD, this is dominant burns, especially in dry season. And also 2 meter, we have also normally the maturity is fibrous until hemis, and also the pH is quite higher than 3 meter, and a little bit burn, especially in the Tuanan area, and predominantly burn, especially the XPLD. It means that after this, often the area is potential to burn is very high. So this is decreasing number of species per hectare. So you can see that in the Tuanan is the color is blue, and VLG, this is the often the area is the color is red. You can see that the number of species per hectare is quite different. After clearing of XPLG, so many species lost. Yeah, so many species can be lost, and the number of species decreased about 72 until 89%. It means that many species lost after XPLG, after clearing. So also in the peat thickness 2 meter, you can see that the difference between location of natural Tuanan and also XPLG, so very different. So and for the 2 meter deep peat, the species can be lost is about 67 until 91%. That is, you can see that the risk of the 3 meter could be higher than a 2 meter. It means that if you often the area 3 meter deep of peatland is more danger than 2 meter. And 2 meter normally a little bit near with the river. 11 hours. So the difference of thickness, the effect of clearance of distribution diameter, you can see that also the diameter, the distribution of diameter of the flange also decrease, yeah, especially if we compare natural and also XPLG. So this is also the structure of the layers, structure of the plant also could very different. This is naturally, they have also many layers, and normally 3 or 4 layers, and also for after clearing this is very dangerous, because in the 1 layer, yeah, this is the evaporation is very high, so it means that quite dry for the peatland. So some consequences of clearing peatland. The clearing of peatland has the effect of reducing the number of species. Peat clearing also affects species density. Clearing peat affect the chance of land fire. Peatland clearing has an effect on changes in the vegetation structure. Peatland have important hydraulic control over watershed areas and the environment, because the ability to absorb water 13 times their weight and store and more carbon. So potential product on peatland will have economic value. I would like to little bit explain about the economic value of peatland. So this is the very important, very famous, yeah, in Kalimantan. We know that this is the kayu ramin. We call that Gonitolis bancanus. This is very fancy word and can be used for making mebel, can be used for making windows or something like that. This is very, but now that's very difficult to find this species, especially in the peatland area. So and this is also very nice species, very good quality of wood. Yeah, Meranti rawa or Soria balangeran. So we can find so easily in the central Kalimantan. But if the area quite open, this species cannot grow very well. They cannot grow very well. So this is very important for us in Kalimantan. If you want to build the house, yeah, for the making construction, yeah, we need that this species, yeah, we call it kayu gelam or Melaleuca leucadendron. This is very nice, very important species, and they can grow in the open area. So they can grow in the secondary forest, secondary peat forest. This is very important species. So this is Jelutung also. This is Jelutung or Dire lawi is very important, especially in the central Kalimantan. Yeah, this species produce gumi, yeah, gumi, rubber, yeah, for gumi, and we export this material to other countries. So this is very important, especially also in central Kalimantan. I found that we call that gemor, Notopoiba cariaceae. So normally this species can be used for mosquito repellent. So this is very nice species. So this is also in South Kalimantan, also in Central Kalimantan, we have the sago or Metrosilon sago. It's very, very important. They can, this is food alternative for the people for the produce the sago starch. And this is Burunticus Elocaris dulcis. This is very common, yeah, especially in open area. This is like grass. They can grow very well and can be used also this, we can utilize this material for making like bag, yeah, like this, and also so many kinds of product like mat or something like that. And also normally in the peatland in Kalimantan, the people cultivate also watermelon, belungka, or pineapple, petai, horticulture, and agricultural others, and so on. And also normally the people also cultivate palm oil, lemon, and also some kind of wood like acacia. Yeah. So this is also very nice, very good fruit. In Kalimantan, we produce a pineapple, watermelon, belungka, and petai. This is very nice and very common, yeah, in our province. So this is the system of the cultivation this is the one strategy. We want to develop upland wetland area. We can use the agroforestry system. For example, this is combined between rubber trees and pineapple, and rubber tree can produce rubber, latex, and also the people can also produce pineapple. This is one strategy. We want to improve the economic value of the peatland area. And this is also, we try also join with the BRG to develop the pineapple combined with allium, pitosolum. This is for fruit, for vegetables. So you can say the combined they can grow very well on the peatland area. This is also, we join with the BRG to combine between Jelutung and fruit pineapple. So this is also, yeah, and this is agroforestry and peatland. This is petai combined with pineapple. This is also possible in the on the peatland area. And could be Pa Nugroho will describe more about the concept of peatland restoration, like rewetting, revitalization, and revegetation. This is one concept to rehabilitate the area or restoration of the peatland area. We can also develop like honeybee or something like that, and also we can also fish we can make a pond for fish, and also you can also cultivate so many kind of fruit. So the conclusion is the clearing of large wetland areas will reduce the diversity of species and the potential for fire. The concept of peat restoration with rewetting, revitalization, and revegetation must be applied to the peatlands. Peatlands have the potential for plant of high economic value as an increase in economic welfare. And the concept of agroforestry is the right concept for increasing the economic value of peatland. Okay, I think this this is my presentation, and I would like to could be next presentation we can discuss. Okay, I would like to give the time to moderator. Thank you very much.
Thank you, Prof. Yudi. This is a very nice talk, and this is very important talk. So who said a wetland is a wasteland? So for those who have any question, please write it down in the chat room, and the operator will deliver all the questions to us at the end of the talk. So now we are moving to the second speaker, which is Dr. Peter van der Meer. So Dr. Peter van der Meer, he was born in Netherlands, Renkum, 1962. So please, the operator for his CV, please.
Jadi kelas dulu Prof. Yudi. Q&A.
Yes.
Sorry.
Right, so this is his CV. So right now it is a very early morning for him in Netherlands. So he has a lot of experiences in doing research as a researcher, and also he stayed in Australia as well, in Victoria, in 1995 to 1998, and after that he continued doing research and as a senior researcher in the International Forest and Natural Management Ultra Research Institute, Wageningen University and Research Center. Right now, he is an associate professor in the tropical forest and sustainable oil palm. He studied PhD in Netherlands and about tropical forest ecology. So please, Dr. Peter, the time is yours.
Okay, thank you very much for your kind introduction. I just try to start my screen. I hope. Is this working?
Yes, it is working very well.
I start to, sorry, no. Now this is the first slide, eh? Sorry for this. So yeah, good morning to you all. Yeah, very happy to participate in this international webinar on sustainability of wetlands. Thanks very much, Professor Yudi, for the invitation. It's a pleasure to be part of this. And I will be talking in my presentation yeah, about peat rehabilitation, and also a little bit about one of the forms how we can do that is in a living lab concept. So bear with me, and I will explain what we will do with that. Yeah, so I'm working for Van Hal Larenstein, University of Applied Sciences. We are a green university. We focus very much on yes, sustainability and sustainable use of the environment. We work also internationally, and here you see a short impression of several initiatives we are working on in Indonesia. I've been collaborating with Professor Yudi already since 2015 on wetlands and on peat. but also in other areas of Indonesia, several colleagues of mine, we are working on several topics, water-related issues. And we have been setting up this Living Lab platform, where together, Indonesian and Netherlands researcher, we collaborate on water-related challenges. And here you see some of the partner institutions, both in the Netherlands and in Indonesia, where we collaborate with. And just to explain, because I suppose the Living Lab approach may not be so well known, it's also a relatively new concept of collaboration, you could say. And it's about finding solutions for complex, wicked problems, and to look how together with several partners from the public, private or people point of view, can be collaborated to solve this problem and to create new solutions, to look for opportunities for testing, to develop new products, new services, and do that all in a real life context. So that's what the term Living Lab is coming from. And that is kind of living laboratorium where we are testing and developing new approaches and new ways for what I told you, some difficult problems. And I think it's here you see the quadruple helix, and it means that together with universities, the knowledge institutes, but also industry and also the government and also the civil society, you look together for solutions for those problems, and you do this in a reiterative way. And so you do that by attacking a small problem, and then set a small step, and then find a solution for that, and then work towards the solution of this overall bigger problem maybe. And one way of doing this is also by setting or involving a lot of students who can very nicely attack each of those separate smaller problems. So, so we had a last year, July, we had in Yogyakarta, we had a Living Lab Water Indonesia workshop where we invited all the different initiatives, and we're also Professor Yudi gave a presentation about our work which we are doing in Kalimantan. Here you can see an overview of some of the living labs in Indonesia, where also Van Larenstein is involved in. That's in Bandung, where we work on sustainable river management. In Yogyakarta, where we work on agroforestry. In West Timor, where we work on climate smart agriculture. And Kalimantan, where we work on peat and paludiculture, and I will be talking about it a little bit further in this presentation. And in Sulawesi, we also recently started a digital farmer field school, where we in this time of COVID-19, we also working on new ways to still continue this collaboration and to also continue teaching at a farmer field school in a digital way. So now zooming in on Peatlands and on the Living Lab in Kalimantan. And this is also some of the words where Professor Yudi started one of his slides with. We have Indonesia has originally a lot of peat areas. They are very much under threat. They have been developed for, amongst others, oil palm, but also other agricultural uses. That's causing in some areas quite a few problems in terms of the haze, in terms of other climate change, biodiversity loss. Also, Professor Yudi in his presentation showed very nicely that in those developed peat areas you are losing a lot of the biodiversity. And one of the challenges is indeed to come to more sustainable systems, to look for both economic and environmental benefits, how to see for ways how you can combine it and how you can make a sustainable system out of those sometimes degraded, heavily degraded peat areas. And here I took some slides from a recently published study by the FAO, on peatland mapping and monitoring, which very nicely shows some of the issues we are working on. This is what you see here. The first slide, I show 3 slides. One is showing a undisturbed peat forest area where it's all, where you have the natural condition. Then one which is very disturbed. And the last one is, okay, looking at how can we restore this. So here, the undisturbed forest, you see that there is a high biodiversity level. We have a nice forest on top of the peat. In this forest, we have all kinds of different species living, and also some of the products are being harvested by local communities, as maybe NTFPs or small-scale logging. And on total, you see also that carbon sequestration takes place. And so, in fact, it's a large sink of carbon, and in that way, it helps to regulate climate change. And also, it's taking up a lot of water, and also the water table is very high. You can see. And there is no drainage, and the water table is very much undisturbed. Now here we move to the situation which we see now a lot of times in, for instance, also in several parts of Kalimantan, where the peat has been opened up, where the peat has been drained. You see here, you see those drains which are causing the peat to lose a lot of the water. And also starts the process of drying out of the peat, which increases the risk of fire, and which causes a lot of haze and health problems, but also releases a lot of CO2 and other greenhouse gases into the air, and which also gives a lot of issues in terms of climate change and the increasing levels of CO2. So you also have biodiversity loss, and what you see also is that the ground, the peat itself starts to subsidize. It gets lower, and you see already the front left part of the peat where you have all the drains. You see that the peat level is a lot lower than in the other areas which are relatively less disturbed, which in the long term will cause problems also for draining, because at a certain moment you will get your peat layer will become so low that the water will not flow out anymore automatically, and you have to start do this mechanically by pumping out of the water. So this is not a situation which is very advantageous for several reasons. So that's why BRG and other institutions in Indonesia have started large programs for peat area restoration, where we are, and one of the things which has to be done is stopping the water flowing out by the canals. So canal blocking is an important strategy, and you see that at the top left area where you have some of the plantations, but in somewhat wetter conditions, to reduce the CO2 emissions, to also reduce the risk of fire and reduce the risk of haze. So I think this is a situation which gives more benefits both for the environment, but also can still be quite productive for humans to and local smallholders, for instance, to get a small income from growing all kinds of crops which can grow under those re-wetted conditions. And that is what we also have been looking at in one of our studies, where we did a desktop review of ecosystem services in those peat areas. And this is a study based in Malaysia, but it also, I think, is very relevant for Indonesia, where we looked at, okay, what can we do now in those drained peat areas which are currently planted with oil palm. And we were focusing in this case a little bit on oil palm plantations. In the long term, those oil palm plantations, they may become very difficult for oil palm to grow there because of the continued drainage and the continued subsidence of the peat. At a certain moment, the peat layer becomes so low that you have a problem with getting out the water. Also, what you see already quite often is that the palms fall over. They are not so stable in the peat areas. So we thought, okay, and also some of the major oil palm collaborations like the RSPO, there was the Round Table on Sustainable Oil Palm. They have been advocating that in deep peat areas, maybe we should be thinking about phasing out the oil palm and looking for other opportunities. And so that is what we did in this study. And we looked at, okay, what species can maybe grow there as an alternative for oil palm? What will it do to the ecosystem services? And what do the stakeholders, the local stakeholders, the small farmers, but also the oil palm companies, what do they think about this? So first we did an analysis of species growing in undrained peat, so really the peat species, and Professor Judy already very nicely showed a couple of the species which are also listed here, but also other more local and fruit species were detected in this study. I won't list them all to you, but you can see here at my slide what some of the major species there. And mostly we found that non-timber forest product species, they could be an alternative for especially providing a livelihood for the local communities living in those peat areas. Now, secondly, we looked at the ecosystem services, and ecosystem services are basically all the goods and the services which are provided by a certain ecosystem, and in this case, peat swamp forest, which are of benefit to us, to humans, and they help to give an income. They can also be important for well-being. And on the left, you see here this box where ecosystem services have been grouped into 4 different categories. The supporting ecosystem services, where it's more about giving a good soil and giving the primary production, but also provisioning, meaning that those are the real products which are being harvested from an ecosystem, like food, but also wood and timber, but also fresh water is important provisioning service. Regulating services is more about climate regulation and flood regulation. And then also cultural services are important, and aesthetic, spiritual, but also educational and recreation can also be an important ecosystem service. Now, and then on the right, you see how they help to contribute to the well-being of humans in terms of security, in terms of basic materials, in terms of health, in terms of social relations and other benefits. So this is the concept we used in those peat areas, and specifically in those oil palm landscapes on peat areas. And we had to be selective. We could not cover all the ecosystem services. So in 3 of those categories, we selected some indicators which where we looked at what that specific ecosystem was providing. And so we looked at the palm oil yield and crop yield as a provisioning service. We looked for the regulating services. We looked at how carbon sequestration was affected. And for supporting services, we looked at pollination, but also biodiversity. And here you see some references which also worked on those ecosystem services. And then we looked at, different scenarios, and how those ecosystem services were being changed under those different scenarios. And the first scenario was basically the baseline scenario, where we have oil palm being grown on peat, and there is a lot of drainage. So the water level you see there is quite low. It's -70 centimeters, meaning that you still have a lot of oxidation and the risk of fire. The palm oil is growing quite nicely, but there are some other negative consequences associated with that. Then we had one scenario where we were slowly phasing out the oil palm to a mixed palydiculture system. And palydiculture system means that we have a wetter system where we go back to the natural water table, which was being depicted in the first slide I showed about the undisturbed peat forest. So going back to the natural situation, slowly over a time frame of about 30 years, you would be slowly cutting away or taking out the oil palm, increasing the water table by canal blocking, and then slowly having a system of palydiculture systems, species, and getting the yield from that. Then we also had a scenario, we calculated that through, where we had an immediate change to palydiculture and then a monoculture, so just gelutong or another palydiculture system. And then the fourth scenario, we looked at how also an immediate change, but then to a mixed system, a mixed viticulture system, where we have a mix of Blutong and Sago and some other products and species. And also there we looked at, okay, what are the consequences for the ecosystem services which are being provided. And so the theoretical study to see what the options are for restoration, you could say, of several functions in those degraded peat areas. Now here's quite a complex table where I won't go over all the details, but you can also read it back in our publication, which we published last year. But basically here we did a scoring of the different ecosystem services. We did a scoring for the carbon emissions, we did scoring for sequestration, we did a scoring for the biodiversity, and we did a scoring for the provisioning. And for each of those scenarios, so you get a kind of matrix. But the bottom line is that the overall performance, which you can see also at the bottom of this table, is that at the baseline scenario where you had the traditional oil palm, of course you have a lot of income from the oil palm, but for carbon emissions and for biodiversity, it's scoring very low. So the overall score, where we combine all those 4 different ecosystem services scoring, you have a score of 38. And the second, excuse me, the second scenario where you go from an oil palm in a transitional way to a mixed viticulture system, you have a scoring of 70%, or 69, sorry. When you have an immediate change to monoculture, polyculture, you have 75%, and the highest score we found when you have an immediate change to a mixed viticulture system, where you have an 81% scoring of your the total maximum of 100% ecosystem services. And again, this is not for some ecosystem services, they're scoring less. So also the mixed viticulture system is still scoring lower for the provisioning and for the income than, for instance, oil palm, but it's doing much better in the area of biodiversity and of greenhouse gas emissions. And so that is one of the reasons why this last scenario was in our study, one of the highest scoring categories. And so in conclusion, those alternative polyculture systems, they can potentially yield more ecosystem services than oil palm plantations on peat. Of course, it's depending on that. That's also one of the outcomes was that stakeholders may not all be, some of course, people working in oil palm plantations, they may be a little bit resistant to this change, but so it depends on the willingness of the stakeholders whether this will take place or not. But indeed, it's made the replacing of the oil palm, both for plantations and smallholder plantations, smallholder oil palm farmers, may at this moment be a little bit too soon, because that's there is not for the economics, for instance, and that is what we're also working on together with Professor Judy and colleagues. And we will, the economics of those polyculture crops, like sago, for instance, or Blutong, there is, of course, a local market, but it's not so competitive yet with oil palm. For palm oil, economic return is much lower. Technically, also, we have to think further about how can you develop those mixed systems, and how also in terms of farming and getting onto the land, and also access of waterlogged land is not so easy sometimes. And also governance issues, like what are the incentives? Maybe it can stimulate it from the government, or land tenure. There are some issues there which need to be solved before I think this system can be really implemented. But I think it's a promising side. So just going back to our initiative where we are collaborating with Professor Judy and other partners on this Living Lab peat restoration. Our vision is that we would like to have degraded peatlands are restored and providing valuable ecosystem services for people, the economy, and the environment. That's through a good collaboration between all the stakeholders who are in one way or another connected to this. And here you see some slides also of Pak Donny from Fordea. He's working in Tumbang Nusa and other areas on peat restoration. We also see Prof. Judy here signing an MOU with the rector of our university, where we have a long time collaboration with. We are very happy with that. And one thing we did during this workshop was to look at how we can develop kind of roadmap. Then you look at, okay, what can be creative solutions, and then D is what are some of the priorities. Now, because of time, I think I will go over this a little bit fast. You can maybe read it back, but we started basically with, okay, what do we want? The top A, we want to have peat swamp forest recovered, we want to have wasteland to valuable land, etc., etc. Then you determine some of the knowledge gaps, which are depicted in B. Then you look at some of the creative solutions which can be applied, which is validiculture, for instance. And then finally, we move to G, and there are some of the priorities where we are working on at this moment, as setting up a steering group, explore multi-stakeholder networks, selection of species, and those are the priority areas where we are working on at this moment. And that is what we have been doing so far. We have had the workshop. Here are some of the results where so far we have several students which have visited the area or did a desktop study on SAGO, for instance, on validiculture systems and validiculture crops. We have worked on several proposals where we are looking for funding and support from the Netherlands government and maybe also the Indonesian government to support this initiative. And also we have been in contact with several stakeholders associated to this initiative, and we are discussing with them how we can develop this further. So at this moment, what we are looking for is to develop this living lab further, a living lab on peat rehabilitation, where we're looking at short-term project activities, but also for long-term partnerships. We also look to involve students and associated universities in this, because that is a very good way, I think, of getting further in those, in solving this wicked problem, you could say. We're also still looking for private industries to join, including oil pump companies, maybe, or other companies on sago or other crops which are interested to join here. We're exploring those multi-stakeholder networks, and the last thing is to try to set up some validiculture trials together with Pak Doni and Ibu Hesti from Bogor, from Vodea as well, to see how things can be developed further. So thank you very much for your time, and happy to discuss it further with some question time. Thank you.
Thank you, Dr. Peter. This very nice talk. And again, for the audience, for the participants who would like to pose the question, please write down in the chat room, and then all the question will be delivered to all speakers at the end of this conference. Thank you. Terima kasih, Dr. Peter. Now we are moving to the third speakers, which is Dr. Frans Suryadi. Dr. Frans Suryadi is, his full name is Franciscus Safarius Suryadi. Bapak Suryadi is Indonesian, if I'm not wrong, but he's Netherlands right now. He was born in 1954. He's very good in Bahasa Indonesia as well. I heard this one this morning, talking to Prof. Yudi. He studied in the Parahyangan Catholic University for his bachelor degree, and he's continuing his study in Netherlands. And now he has a lot of employment record, and also he has a very big research experiences, such as hydraulic engineering, land and water development. And he also did a project about a river engineering section, a research center for water resources, swamp and coastal engineering, are located in Bandung, Indonesia. So if I read all his CV, is a lot of pages of his CV, so I'm pretty sure that Dr. Suredi has a very big experiences and very expertise in his field. So now let's give a time to him to do the talk. Suredi, please, the time.
Okay, thank you, Ibu Moderator. Terima kasih, Bu.
Sama-sama.
Okay, can I? Where is that? In this webinar, I will try to present a little bit about potential and constraints of tidal lowlands development for that lowland areas. As Professor Yudi mentioned already, okay, talking about lowland areas in Indonesia or wetlands, you can see on this map, they are distributed in Sumatra, Kalimantan, and also
excuse me,
Papua.
Pak Suredi, could you please put it in the full screen, please?
Yeah.
Thank you.
Full screen.
Sudah, Bu. Oh iya.
I did already or not? I did already. Did you see that or not? So, yeah, Bu.
Full screen.
Is it on full screen? Huh?
We still see it in slide.
This is Word, Bu.
Yeah, that's all right. That's all right. Thank you, Pak. Maybe it's a long way for me. Thank you. No worries.
Is it already?
It's okay.
Yeah? Yeah? May I continue?
Yes, Pak. Please continue.
Okay. Now, I like to discuss a little bit about potential and constraints. And then that maybe we should consider also about human resources. Talking about wetland or lowland development, but to be honest, in Indonesia, how about the human resources? We should think also about that. Yeah, and talking about lowland areas, as Professor Yudi mentioned already. The first thing, of course, about the soils. Now, if we look at these lowland areas in Indonesia, mainly we have two types of soils, peat or gambut, and also clay. In this particular area, we have to be very careful. Maybe when we have a clay soil, maybe we have a potential acid sulfate soil or pyrite. Now, of course, its type of soil characteristics. And then, of course, when we consider to develop it, we have to know it really, the characteristics and how we have to treat these soils. About soil and water management for our lowland areas. These peat soils or potential acid sulfate soils. As Professor Yudi mentioned also, if we we provide a proper soil and water management, and then lowland areas, we can expect a very good performance, maybe for food crops, or for rice, or maybe for other crops, fruits or vegetables. As I said, to develop, really we have to consider the human resources, about the knowledge and know-how, theoretical and practical. Here I show to demonstrate a little bit. We are talking about lowland areas. We are talking about tidal lowlands. So it means we may expect the influence of the tidal movement. Then if we have that tidal movement, so it means we may expect also salinity intrusion. The salinity intrusion. Then if we like to develop, to conserve the area, really we should understand, we should know the effect of this tidal movement, and also the consequence of that. We have salinity intrusion. Yeah, of course, next to that, we have to know about hydrology, hydrodynamics, soil, social, environmental science. And the most important parameters for lowland areas, we are talking about lowland areas. So it means the topographical conditions, the area, topography. As we know, lowland areas are very flat, so it means topographical conditions will play a very important when we design soil or water management system. So it is really, I think, the knowledge and know-how of these tidal lowlands or lowland areas is really very important. Again, back to lowland development in Indonesia. Actually, we did start already. We did start. Now, at that time, of course, we don't know too much about lowland characteristics. As the result, after some times, we are facing at the time a problem with water quality, especially acidity. As Professor Yudi mentioned also, in some schemes, the pH, the acidity, really a problem. pH even lower than 4.5. No, but of course, after so many years, more than 30 years of the development, there are already, by nature, is a leaching and flushing of that, let's say, toxic or acid materials. As the result, from the monitoring and evaluation activities in some schemes, we measured pH, and then in fact, now pH is already much better than 25 years ago. Huh? So what does it mean? So it means if we like to improve, to develop that lowland areas, this is a time actually to do the rehabilitation or to do the upgrading, to improve the soil and water management systems. Yeah, of course, Professor Yudi mentioned also about the fire of peatlands, etc., etc. This kind of things we should be to solve it, as Professor Yudi mentioned. Soil moisture content. The options is to control the groundwater table. So based on that, actually, to develop the lowland areas, the first step, we should know about what we call land suitability of that area. What does it mean? That area, it doesn't mean that, yeah, we can grow immediately the rice crops, for example. As we know, maybe there potential sulfate soils. So it means we should do what we call a land suitability analysis. Now, for lowland areas, especially, as I said, the influence of tidal movement and also the topographical conditions of the area. Now, we have to check it carefully. The correlation between topography and tidal effect, we define it as hydrotopographical conditions. Of course, all of us, we know, talking about tidal lowland areas, we have 4 categories of hydrotopography: A, B, C, D. I will not discuss in detail about these classifications, but in short, we really have to know about these hydrotopographical conditions of the area. If we know these hydrotopographical conditions, and then after that we know about the soil conditions, maybe we have a peat layer, acid sulfate soils, parameters, let's say, hydrotopography and soil conditions, we can start to design what kind of soil and water management systems for that areas. Why I said about soil and water? Because, as I said, the soil, they have a special characteristics there. If we did not consider it carefully, and then we may expect that we may have acidity problems, or we may have a fire situation during the dry season. So again, if we know that, we can make a proper design for our soil and water system, water management system. So it means to provide the acidity problem, we have to consider how to do the leaching, how to leach the acid materials or toxic materials iron elements to leach it from the soil system. And then, of course, they will follow the water particle and then flow into the canal systems. And then, of course, the next step, how to. So it means leaching and flushing is very, very important. Now, again, talking about hydrotopographical conditions. So it means we may think, oh, for example, for category A, so it means we may expect a tidal irrigation during high tides and drainage during low tides. So it means we know, but if the area is under the C category, so it means we may not have tidal irrigation. So instead of tidal irrigation, we may consider rainfed, for example. So it means very much different between category A, B, C, or D category. Next, said, if we did not consider it carefully about hydrotopography and soil conditions, in case we have potential acid sulfate soils, so we may have the situation like these slides, left part of these slides. We have this situation with iron toxicity. So you may realize if you look at the field conditions, the color is a little bit red. So it means there's a problem with iron. Now, as I said, if we may provide proper soil and water management, and then we may expect also the performance of the system like the slides on the right side. For example, in this case, rice can grow very good in lowland areas. And of course, the yield will be quite high. For example, in South Sumatra, in Delta Upang, Delta Telang, they may expect crop intensity 200%, even now more than 200%, 200% rice, and then they have also dryland crops. So, if I may make a summary, really land and water management is the important aspects, the important parameters. So please consider if we have a peat soil or if we have a pyrite soil, and then we may have a different water management systems. Then maybe an illustration about peat soils in tidal lowlands. I think about 10 years ago, there was a study about sustainability of the peatland areas in Indonesia. Of course, as Professor Yudi mentioned, that in Indonesia we develop already quite large areas on Sumatra, Kalimantan, and then again at a time 30 years ago or 35 years ago, we did not know too much about the characteristics of lowland areas. So the result is maybe we develop the area where the peat layers is more than 3 meters But from this study, AGRO-CLIMATIC, it is very clear that if we have a peat layer more than 3 meters, we should not develop it. We should conserve it. But of course, because at the time we don't know, so yeah, we did it already. So it means we have an adaptive sites. It will be clear that if we like to develop the peatland areas, so we have to consider the thickness of that peat layer. Can develop it very well, where we should conserve it, and then where we have an adaptive part. Now, the next slide's example in the Netherlands. In the Netherlands, there are also some places with peat soils. This is north of Amsterdam, Giethoorn, the name of the area. This is really peat areas. This is to show you the water management there. As we said, peatlands, and then we have to try to control the groundwater table, to set the groundwater table as high as possible in order to avoid land subsidence and also the oxidations of the organic materials. Then here in Giethoorn, they can maintain the groundwater table very well. As the result, you see on the slides how they develop this village. This village becomes very famous, and then sometimes even they call it Venetia van Holland. So it means in Indonesia also, if we can develop, we can control the groundwater table in peatlands in a very good way. May expect also something like this. Also, previous presentations, we are talking about, to control the groundwater table on peatlands. And one of the options by using the canal blocking measures. Now, the basic concept is quite simple. Of course, you have a canal, then you have a water flow to the downstream direction, and then if you may design to install some structures, simple structures there, then you may expect that you have a proper groundwater table in that area. So it means, of course, you have to know about the hydrological conditions of the area. You know the topography, and then after that, you can simply use should be, and then the distance between two structures, how big the distance, etc., etc. Basically, this is quite simple to model it. As I said, basically, we try to control the groundwater table as this upper figure. Now we put the blocking structures here, and then of course upper part. This thing, or here we have a peat dome. As we said, we know, okay, peat dome area, actually we should use it as a water storage area. Then again, by using this approach and then this kind of models, we can do it. We know how large the area that we have, and then the lower part, we should apply this canal blocking strategy. Then the next slide, as I told before about sand, and we develop the lowland areas, peatland or acid sulfate soil or pyrite. We should do what we did for South Sumatra, the Delta Telang in South Sumatra. We check about the hydrotopographical conditions, the area where they belong to category A, B, C, or D. And based on that, we do the land suitability analysis. And as the result, we can display it here. Left side, it is the present conditions. You see the different colors with the different conditions. Now, the dark color, the dark brown color means low spots. So it means it is a hydrotopographical A, hydrotopography A category. This is the area. And it means that if we know the land suitability, we can make a proper design of water management system there. In this example, we did also another scenario. Let's say if we have a sea level rise in the coming years. So it means the water level becomes higher. Then, of course, it means that we will change the hydrotopographical conditions. It means the result is the land suitability will change as well. The result is the right hand side figure. This is just to show you, actually, we can do this kind of analysis to design the present water management conditions, and then also if we consider about climate change, sea level rise, and then what should be the water management system in the future. So finally, I like to present this summary. The potential and constraint have to be checked carefully if we like to develop or to conserve the lowland areas. And then hydrotopographical conditions for tidal lowlands is really important. Please check it before we develop that area. Soil and water management is really an important aspects to be considered, especially related to the leaching and flushing possibility or capacity of the systems. Now, peat layer, I should say, more than 2 meters, we should not develop it, but we should consider to conserve it. And lowland areas with pyrite or potential acid sulfate soil, as I said, if we did not do it carefully, you may expect the oxidation of pyrite materials as the result. After some times, you may have a low pH there. So it means we have to consider leaching and flushing. If we develop it from the beginning, that potential acid sulfate soil, we may consider 2 strategies. The first strategy is to avoid any oxidation of pyrite materials. So it means we try to control the groundwater table to put it as high as possible. This is the first option. And the second option, we said, oh, okay, we have a potential acid sulfate soil. We develop it. Okay, we maximize the oxidations. So it means we lower the groundwater table. So it means we may have oxidations of that materials. But after the oxidation, we say, okay, flushing. Leaching and flushing, that's also possible. Now, of course, other option, we may consider also liming to use a kapur, but it is very costly. We should not consider it for large scale area. I think this is all what I like to present. Thank you very much. If there is any question, feel free to ask in English or in Bahasa. Thank you very much, Ibu Moderator.
Thank you. Terima kasih Pak Suryadi for a nice talk. So we are starting to collect some questions right now. Again, if the participant and all of you would like to pose a question, please put it in chat room, and then we're gonna deliver to all the speakers for today. And now we are coming to the last speaker for today. Bapak Insinyur C. Nugroho S. Priyono, MSc. Bapak Suryadi, could you please turn off the...
Yeah, I will try.
Yeah, all right, thank you. Stop this share screen, please.
I cannot get it.
Just stop sharing, just click on it.
I did not get it.
Pojok atas, Pak. Sorry, bahasa Indonesia.
On top of the Zoom.
I did not get it.
Pojok atas, Pak.
Ya.
Di tengah.
Or maybe house can stop it.
Dia keluar langsung.
Keluar ya Bapak Suryadi. Masih ada. Di atas Bu Mutia bilang aja Bu, di pojok atas, di tengah biasanya ada. Nah ya ada.
That's all right. Right. So now we continue for the last speakers. Please, the operator, share the screen for his CV.
Yes.
Bapak Nugroho Sulistyo Priyono was born in 1960s. Now he's working in BRG, Badan Restorasi Gambut Restoration Department in Indonesia, Peatland Restoration Agencies. Before he finished his bachelor degree in Gajah Mada University, and after that he continued study at Massey University in New Zealand. Now he's an expert doing a research about soil conservation and watershed management research. Now the time is yours, Bapak Suryano. Nugroho, I'm sorry. Yeah. Please, thank you.
Okay. Thank you very much, Ibu Dr. Mutia, as a moderator. Honorable Professor Yudi, Honorable Peter van der Meer. I think we met before, Peter.
I think so too. Yes, yes. Maybe it's Jokja or maybe in the Netherlands. Yeah. No, nice to see you again.
Yeah, thanks. Yeah, Honorable Pak Suryadi, Dr. Suryadi, and all participants in this international conference. It's my pleasure being in this conference, and thank you, organizing committee, for inviting me in this occasion. I would like to share the screen. I'm trying to interpret the topic of the seminar. I got a flyer mentioned about at least 3 parts of the topic. The first is about biodiversity, and second is about commercialization, and the third part is about sustainability of wetland. Or in this time, I'm going to talk about peatland. Based on this information, I'm trying to divide my talk into 3 parts. But before I'm talking about the main topics, allow me to introduce my institution, which is called Peatland Restoration Agency in English, and usually you recognize it as in Indonesia, we call it Badan Restorasi Gambut, or BRG. I think everyone knows about BRG. So in the next, I'm going to mention BRG rather than Peatland Restoration Agency. Let me mention about introducing of Peatland Restoration Agency. The Peatland Restoration Agency was set up in 2016 based on Presidential Decree number 1, year of 2016. Our task is to coordinating and facilitating of peatland restoration program in Indonesia, and we work in 7 provinces, which has got peatland area, and there's the most peatland areas in Indonesia. Starting from the eastern coast of Sumatra, from Riau province, and then Jambi and South Sumatra. In Kalimantan Island, we work from West Kalimantan, Central Kalimantan, and South Kalimantan. And also one more province is in Papua province. I'm sorry, I'm camera. Enter. Yes, enter lagi. Ya, apa gitu? Loh. Coba bahasanya. I got the trouble with the print screen. Okay. Next, please. Well, I'll continue that. Within the 7 provinces, we have a special task to restore more than 2 million hectares, yeah, that need to be restored. According to the presidential decree, it mentions about 2 million hectares that need to be restored. But also we more closely look at this criteria that that area need to be restored according to the canals, peatland depths, and fire. We finally find that the restoration area needs to be 2.6 million hectares, which has to be achieved within 5 years. When we started in 2016, and this year is the final year, we have to restore 2.6 million hectares. And this target is distributed into 5 years. Each year has got a particular target. Yeah. Usually between 20% up to 30% in the first year. And this final year, 2020, we only have to finish another 10% of our target. But our target is also not only private area, but also concession holders area and conservation forest and production forest. They have different authority on this particular area. For instance, in BRG, we will focus on private area. When we work on the conservation area, we are going to collaboration with Ministry of Forestry and Environment. But in concession area, according to our regulation in Indonesia, they have to manage their own concession and they have to overcome their own problem when they got a fire, for instance. So BRG don't come to the concession area, but focus on the private area, production forest, and conservation area. In terms of conservation forest, we coordinate with the Ministry of Forestry and Environment. Next. Like it's very popular for the approach and techniques in terms of peatland restoration. We are using three approaches. The first is R1, this rewetting. We need to rewet peatland area that's already dried by canals, drainage canals, of course. And second is revegetation, that we need to revegetate the peatland area that already is cut off. And the third R is revitalization of livelihood. It's very important. This is already not in biophysical treatment, but this approach, it's very interesting and important because we have to provide the particular condition so that enable our technique can be applied in that area. Let me mention about the achievement in the concession area and non-concession area. After 4 years, this data and up to 2019, this is a target of non-concession. This is a concession area. If you see this here, concession area, we still blank of the data because we cannot access the data from the concession holders. But for the non-concession, we have complete data, the peatland restoration, which is already carried out in this non-concession. Yeah. Oh, this is yeah. Overall achievement, I should mention after almost 5 years, this data was up to 5 years because the last collected was in June 2020. Ini dihilangkan misalnya. Supaya gede. For the R1, through the implementation of Peatland, we have a unit of yes, of infrastructure of pit rewetting. Yeah, the total is 2,015 units that have been built. Yeah, in the whole area, 7 provinces. More than 6.9 canal blocking, and more than 15.6 thousand deep wells in the peatland area, and also 409 canals backfilling. Yeah, for canal blocking, of course, this is a particular technique to re-wet that area because we block the canal so that the water can laterally infiltrate to the lateral areas. A pit well, it doesn't mean to fight the fire. A pit well fires because this is not our task in BRG. What our main task is to re-wet so that enable fire cannot come in that area. But we don't fight the fire. And total intervention area until early 2020 is almost 800,000 hectares. According to 2 weeks, he mentioned that it's almost 4 times similar with peatland restoration in Europe for along the history. So this is very ambitious target, but finally in the non-concession area, we achieve almost 800,000 hectares. So we hope that by the end of this year, we can achieve our target. Yeah. For the revegetation, for the revegetation, we already covered almost more than 1,000 hectares area within 7 provinces. And in terms of community livelihood revitalization, the total of 933 packages consists of 413 packages, productive economic assistance, and more than 500 packages for community livelihood revitalization. So this is a achievement of implementation during 5 years of BRG. Yeah. Thanks. Yeah. We are going to main topic now. the first is about biodiversity in tropical peatland. Probably not too many research that has been carried out in that area in terms of biodiversity. But we are lucky because we have opportunity to set up the research on biodiversity in peatland. According to the literature, that tropical peatland is actually rich of biodiversity, the most diverse of peatland environment, among the most threatened. In the Southeast Asia, we've got more than 1,500 plants, more than 100 mammals, and more than 200 birds and freshwater fish. We also have research on coastal birds and water birds, which are actually the biological indicator that if we can re-wet the peatland, the water bird will come to that area as their ecosystem, their habitat. They will come back to the wet peatland. So we also have research on water birds. In natural lowland peat swamps in South Asia, vegetation forming catena of types from the perimeter to center, change reflected by canopy height, peat thickness, waterlogging, and nutrient availability. Next. I would like to mention about particular research on biodiversity in the peatland. We are trying to divide the cross-section of peatland ecosystem into several segments. We call it the zone, particular zone. And we come to the untouched, if you can call it untouched peatland area, which is, we call it in Tasik. Tasik is a particular small lake in the top of domes, of peatland domes. This is unique because usually a lake is in the valley, but this lake is in the top of the peatland dome. And we can find Tasiks in many places in Rio province down to Jambi. The first segment is in downstream, and the second going up until about 4 segments here. And the zone 1 is the downstream. We call it water segment, and then if we going up to the upstream, we will find various of vegetation. According to the next year, according to the inventory, as an example of biodiversity in the lake ecosystem, which is we call it Tasik. Our research in collaboration with Gajah Mada University, Sudirman, Jenderal Sudirman University, and Riau University in the last 3 years, we find 52 species of trees, 39 species of birds, 5 of them are protected species. So huge of species we can find in that area. 9 species of dragonfly, and 29 species of plankton, 60 species of microalgae, and almost 45 genera of nematodes. So we're still searching another biodiversity that we can get a figure of how rich that area. And next to the commercialization, basically, we start with identifying the potential commodities in peatland. Yeah. In 2017, we indicated that at least 15 of potential commodities, which is utilized as a paludiculture in the peatland area. Yeah? I don't mention one by one, but I will talk about at least 3 important species. The first one is sagu, yeah, sagu, because it's already mentioned as Professor Yudi and Dr. Peter about sagu as well. Sagu is mainly special for peatland area because it is suitable in the wet ecosystem. Yeah. And in Sumatra in particular, we can find under the trees a lot of pineapple utilization. And now in Sumatra, particularly in central Sumatra, we'll find cassava plantation. And also in Sumatra, in central Kalimantan, I mean, also in Sumatra, of course. Yeah. Despite the paludiculture, we also identified the important poultry, particularly in Kalimantan and some parts of Sumatra, is a duck. Yeah. And livestock, this is in particular in South Sumatra. There are many of swamp buffalo. It's got particular ecosystem, wet ecosystem. They live in swamp area, and also aquaculture. It's very popular in central Kalimantan. There are so many local species of fish, yeah, like ikan petok, ikan gabus, yeah, and etc. Yeah. In terms of paludiculture, I would like to mention about our research in collaboration with Center for Forest and Environment in Palembang, which basically combination of 3 approaches that we usually do. We call it concept of agro-silvofishery. It means that we will cover the agro, it means agronomic, and silvo forestry, and fishery is also for fish utilization. So in the reality, we have, in the real condition, we have particular plot demonstration. Let's it's about 4 hectares, and this year we enlarged to be 10 hectares, this plot. We divided into several segments. In the middle one, in the center, is the area for silvo, it means for forestry. Yeah. And we've got a rectangle. Yeah. This water is not flow out of that area, but this water only on this ditch, rectangle ditch, and also particular area that is used for paddy and also horticulture. So we have agriculture in the edge of the ditch. In the middle, we have forestry commodity, and we have fishery in the ditch. Yeah. So this is a combination of 3 approaches that I have mentioned before. Got many. Next. Nah, the last part of our topics is about the sustainability. I understand that this sustainability, this topic is sustainable management of peatland. So to enable management that could be sustained, the peatland restoration has to be a movement, not only a program, but also has to be a movement that's supported by all stakeholders. To achieve that condition, we have to implement social engineering that must be implemented that enable all entities, all stakeholders involved on the program. So we don't only deal with biophysical and technical aspects, but we also deal with social aspect, education, socializations, participation, and partnership. Yeah, so this is a sort of condition that enable technical and biophysical can be applied on that area. Yeah. Next. Now, the next I would like to mention about achievement in terms of social engineering. We have implemented more than 500 peat care villages. We call it Desa Peduli Gambut. Yeah. Along our in the spread of our target provinces, start from Rio down to Papua. Each province has got more than 100 villages, particularly in Rio, Central Kalimantan, and this is 2 provinces, and also West Kalimantan, we've got 90. South Kalimantan, we've got 66 villages. Jambi, we've got 44, and South Sumatra, we've got 73. In Papua, this is a different case of Papua because we've got disturbed, if we call it disturbed peatland in the Sumatra and Kalimantan, but in Papua we will find undisturbed, mostly undisturbed peatland in Kalimantan. So they have got a different approach. This method is not the same as in Kalimantan and in Sumatra. Next. The role of community on peatland to achieve the social engineering, we have to involve most stakeholders. Yeah, start from elementary or primary school teacher. More than 500 we have educated them using very simple playing tools for pupil. And then paralegal, we also educate, train the paralegal in that area. More than 700 paralegals already trained. And facilitator for Desa Peduli Gambut, community group members, yeah, more than 7,600 people. Also, the priests like Dai, pastor, yeah, pendeta, farmers, of course, yeah, and also food artist. This is a sort of a chef, you know. This is basically we want to involve many groups that can be as influencer that influence people to ask them involved on the movement of protecting and restoring peatland. I think that's all that I'm going to talk about in this occasion, I hope that can give you a figure about what we have done and what we are going to do in the next phase of BRG, because this year is the final year for the first phase of BRG. We hope that next year we have different program, not only to continue, but also we are going to use a different approach that needs to be very specific of that area, because each area has got their different characteristic that need to be treated. I think that's all, Ibu Dr. Mutia. Thank you for this occasion.
Thank you very much, Bapak Nugroho. Well, this is all the speakers, our speakers for today. So we still have another 2 sections for until the end of this webinars. Please, you still have time to pose your questions, and then please, all the participants. Just stay until the end of the webinar, because we are going to have the photo session at the end. So now we have still a couple minutes for a panel discussion. There are several questions already posted in the chat room. I would like to deliver first question to all the speakers. The first question is for Professor Yudi. Question was delivered from Ibu Betty Agustina from Education of Biology Pasca Sarjana ULM. The question is, I want to ask about the extent of Indonesian peat swamp forest, predicted to be the same as the area of the peatland in Indonesia. Please, Professor Yudi, to answer.
Okay, thank you very much. Adik nih ya, Betty Agustina. I think the question is the extent of Indonesian peat swamp forest. Yeah. So if we talk about the areas, of course, this is quite similar. Yeah, the area of the forest, peat swamp forest, and also the area of the peatlands. But if we say that about the quality of the forest, I mean that the condition of the forest, of course, is different, because you know that every year we have degradation of the forest, the reduce of the quality of the forest. It means that the quality of land, or the quality of the fertility of the soil. This is very different between forest area and the area, because sometimes the people say that area is the same with the forest area. Area is different with the forest area. So area is declared by the governments to say that how large the area of peatland. But the quality, this is the utilize of the forest area. I think like this, Bu Mutia. Thank you very much.
All right. The question posted by Ibu Betty Agustina. The second question was posted by Ibu Nazarni Rahmi from Baristan Banjarbaru. This question is also for Prof. Yudi. The question is, do horticultural crops grown on peat provide the same productivity as those grown on normal land? The second one, are there any other effect on the crops produced from these peatland that might affect the health of the human who consume that product?
Okay.
Please, Professor Yudi.
Oh, thank you, Bu Mutia. Ibu Nazarni Rahmi, ya, is right?
Yeah.
Yeah,
correct.
Thank you for the questions. Of course, I said it before that peat swamp is quite marginal soil. I mean that not so fertile. But if we compare with a normal land, I think that this is normal land is like fertilized of the soil. Yeah, the soil is fertile. So of course it's different. Normally in the normal land, they can the productivity is quite higher than peatland. But this is depend on the species, depend on the plant. For example, not all species can grow in the peat swamp, yeah, because only some species. We mentioned that before. For example, the fruit like watermelon, like pineapple, and something like that, they can go very well. They can adapt in the peatland area. But normally they cannot grow in the mineral lands. No, this is the depend on the species, and also the kinds of wood. Also, not all species can grow in the peatland. For example, I mentioned before only some species like glam, like gamor, like soria, and also ramin and something like that. So. And the second question about the effect of the crop products from the peatlands. Yeah, of course, this is not so a problem with our health. Yeah, I mean the health of human, but this is depend on the pollution. Yeah, as long as no pollution in this area, this is no problem for health. If we have the pollution in this area, for example, like so you can use, for example, like fertilizer, chemical fertilizer, for example. This is of course this is effect sometimes because they use the chemical, yeah, and also some kinds of pollutant, yeah. This is also can influence our health. It means that this is depend on the pollution of the soil. And I think like this, Bu Mutia. Thank you.
All right. Thank you, Prof. Yudi. Hoping that Ibu Betty and Ibu Nazarni Rahmi could understand the answer. If you still have more questions, you can pose the next times. The last two questions from Bapak Theophilus Budi. These questions are also for Professor Yudi. The first question is, how can this peatland really be used properly as long as there is no understanding from the community? The second one, how can this peatland really be used properly? Oh, sorry, this is only one question.
Okay.
Please, Professor Yudi.
Thank you very much, Bu Mutia. Bapak Theophilus Budia, thank you for your questions. Of course, before we use the peatland area, I mean, we must consider the characteristic of the peatland, because if we don't know that characteristics of the peatland, this is very, very difficult. Sometimes we destroy the peatland. So, for example, not so large area must be open, because you know that in large area, if we open the peatland in the large area, sometimes you know that evaporation, especially is very, very high, especially we have in the tropical area, and sometimes so easy for the peatland can make like dry peat. This is very easy. Burn, for something like this, and also to reduce the fertility and something like this. So we must understand about the characteristic of the peatland. So and also we must also consider the rewetting. Rewetting is mean that the area must be the area of peatland must be wet, because if the area of the peatland not wet, sometimes the problem I mentioned that with fire, with fire, and also irrigation of the, for example, if we cultivate like this in this area with a crop or a rice field or something like that, this is also a problem. I think like this, Pak Mutia. Thank you very much.
Thank you very much, Professor Yudi. Now we are going to deliver a question posed to Dr. Peter.
Mm-hmm.
The question is from Ibu Nazarni Rami from Baristan Banjarbaru. Her question is, as previously stated, the wetting scenario is still not realistic from an economic and technical perspective. What action and solution can we take to make it real? Please, Dr. Peter.
Mm-hmm. Yeah, thank you. Yeah, thank you, Ibu Nazarni, for this relevant question. And I think indeed actions and solutions to overcome those impediments. And I think when you look at, for instance, the economics of re-wetted products and or products from re-wetted areas, I think we have to look at, for one thing you can do is look at the value chain and how it can be grown and how it is brought to the market, and you can improve all aspects there. And also looking at the market itself, whether you can develop markets in Indonesia or neighboring countries, or maybe even outside South in Europe or America, and looking for international markets for the products you are growing there. And I think it needs to be addressed in a systematic way. I showed you one example of a student of ours, an MSc student who did her thesis on the value chain of sago, and I think that is one thing by collaborative student work and also own research, then we can overcome those economic issues. And I think the same for the technical issues. I think also there we need to maybe set up trials. It's good to see that Pak Nugroho, his team, is working on those trials in real life situations. How can you re-wet areas? What crops can you grow there? How can it be done technically? What does give the best yields? What gives the best other ecosystem services? How can you access still the land under wet conditions? Those are things which need to be, I think, investigated in those trial settings, and then slowly, together with private industries and maybe local governments and local initiatives, be tested further and developed further. But I agree, it's a difficult one, but I think we can make progress by using all the different resources we have. Thank you.
Thank you, Dr. Peter. The following question is from me, Dr. Peter.
Okay.
I would like to get some advice or suggestion for you regarding to how to improve the ecosystem services, especially in South Kalimantan, because I think the typical of the wetland in Kalimantan, especially in South Kalimantan, is a bit different than other provinces in Indonesia. Thank you.
Okay, yeah, thank you for your question. I think how to improve the overall ecosystem services, and maybe looking at the ecosystem services are a broad term, are a general term, so they can several aspects of that. But when you're looking at, for instance, biodiversity or carbon sequestration, I think it's important to start to revegetate certain areas. Also, one of the things which is being done by BRG and other initiatives to using the 3 Rs. And also experiments which are being done in Tumbang Nusa, which is Central Kalimantan, which is maybe slightly different from South Kalimantan. But I think there are also experiments show that it can be done. You first have to look at which species can grow there, what ecosystem services do they provide, how can we grow them in a kind of mixed system. You have to look at the landscape setting, where can you plant certain trees. That was also nicely done by the presentation from Delft. And I think that is by looking at all those factors, you have to determine which ecosystem service you can stimulate at a certain area. But it's, yeah, sorry, I have to keep it a bit general, unless if you want to address one specific ecosystem. Yeah, in South Kalimantan, but also are you envisioning one specific ecosystem services? Are you talking about biodiversity, or are you talking about production, or what can you specify that a little bit more? Sorry?
Yeah.
Yeah.
Yeah, especially so it's about production crops. Yeah.
Yeah, about production of crops, then I think, yeah, indeed, you should be looking at the specific conditions in South Kalimantan, the specific conditions of the peat, the specific conditions of also the communities which are, and the smallholders which are using these peat areas. You have to look at the specifics of the markets, what market is there, for instance, for Perun or for Jelutong or for pineapple or other crops which you can grow there. And what is the local knowledge in growing those crops as well. And then by staking that baseline inventory, then you can try to look how you can reach a certain new target in the future if you want to improve the productivity of degraded peat areas. Well, you have to develop the strategy. You have to look at what is possible there. How can we improve, for instance, the water table? Is it possible to stop the oxidation and the burning? So it should be tailor-made. But I cannot give you one recipe for which fits all the whole area of South Kalimantan, because that is also quite large, of course. So you have to look at the specifics of each region, look at the possibilities there, and then start with local communities and also knowledge institutes, I would suggest, and private industries to look for solutions.
Right.
So I hope that answers a little bit of your question, but
right. Yes, sometimes we have problem in like how to improve, but we still have problem how to maintain and sustain that project. So sometimes that's a big gap for us as a researcher.
Yeah, no, I can imagine. Yeah.
Yeah. All right. Thank you, Dr. Peter. We are moving to Dr. Suryadi. There is other questions posted by Ibu Siti Hamida. Could you please show something like a local production from Kalimantan other than Sumatra, which is based on wetland communities, as where the Indonesian actually is coming from the wetland areas? Please, Pak Suryadi.
Yeah, sorry, Ibu Moderator. Could you please repeat it once more, please?
All right. Yes, there is another question posted by Ibu Siti Hamida. She would like to ask you about the specific local production from Kalimantan or other island such as Sumatra, which is based on wetland areas, which is actually our grandparents coming from the wetland areas.
Yeah. Okay. Of course, I simply put one example. Of course, there are many examples. Yeah, actually, I can put more. For example, if we go to West Kalimantan, they utilize also peatland areas for growing aloe vera, lidah buaya.
Right.
It's very famous there and very valuable crops, let's say.
Right.
Now, other things, as you said, Pak Yudi also said that is pineapple and nanas. Also, yeah, I will try to check again. If I have more, I will, send it to you.
Okay. All right, I think that the question is already answered for Ibu Siti Hamida. I still have another question for Pak Suryadi as well.
Yeah.
Could you please give us some idea how to reduce the salinity during intrusion of the seawater into the wetland or the peatland areas?
How to reduce?
Yes.
How to reduce? Yeah.
The salinity intrusion.
Yes. Look,
because
salinity.
my research is like regarding to the water treatment. I'm doing the designing process using the wetland saline water. It is a big problem for me because I'm using the membrane technology to reduce the salinity of the seawater. Yeah. We got a lot of rivers that we cannot control of the intrusion.
Yeah, as I said, salinity intrusion is a natural phenomena. So it means, first depends on the tidal fluctuations and also upstream discharge from the river. We are talking about maximum salinity intrusion that happen during spring tides, pasang purnama, and also during dry seasons. So it means the upstream discharge is minimum, small, and then you make back a big salinity intrusion or far from the estuary. Yeah, but how? Hello.
Yes.
Yeah. And then how to provide it? Okay. As I said, this is a natural phenomena. In our water management system, we may consider maybe hydraulic structures to avoid that intrusion. But it is not that easy, but it is possible. So it means if we have a hydraulic structure in our system, and we know from our tidal prediction when will be the spring tides and in the dry seasons, and then we can prepare and then make an operation plan for our hydraulic structures. But without that, in open systems, simply we cannot avoid it. We have that. Is it a bit clear, maybe, Bu?
Yeah. I think it's a bit big deal for us. It's still there is a like big job for us to do that. All right.
Yeah.
Thank you, Pak Dr. Suryadi.
My pleasure.
All right. The last question might be, I would like to also to pose question to Bapak Nugroho, because Bapak Nugroho know all about restoration, Gambut Restoration Agency, where I also tried to join. I also joined that project in 2017 with Prof. UD and other teams, where we tried to do the to create the unit of filtration to treat the wetland water to be the clean water. Using the filtration unit. So as a global that you have data around Indonesia about wetland or gambut, how many percent BRG actually in roughly already covered the problem, the whole way in Indonesia that we face? Please, Bapak Nugroho.
Yeah, thank you, Bu Mutia. It's very difficult to answer the percentage of the coverage, but our main target, 2 million hectares, is our priority. It does mean that this is the priority area that need to be handled first. Yeah, when we ask the percentage that already covered from the 2 million hectares that the priority damage peatland, yeah, that need to be restored. Only almost 1 million hectares is a private land area. So that half of that we have covered by this year. So, but if we compare to the total area of peatland in Indonesia, we've got, according to the latest map, which is issued by Balai Besar Sumber Daya Lahan Pertanian,
Right.
it's about 14 million hectares. It's just one of seven part of 17 million, 14 million hectares of the total peatland. So still, big area that need to be treated, Bu Mutia.
Right, it's still a big work to do in the future, right?
A lot of work to do, but we can do by ourselves. We need to create the movement of everyone needs to treat it. So otherwise, it's not to be covered because it's so huge of the area. I think that's all.
Exactly. All right, I understand, but Nugroho, yeah, because a huge land and a lot of problems that we face. We need more researchers to do their research, how to maintain, how to sustain, and how to develop, and how to improve all the problems that we face. All right, so I think because of the limitation of the time, we have to go into the last session. As a closing session should be would be delivered by the director of PHLB ULM or Professor Yudi Firmanur Arifin, but I would like to remind all of us here, please stand by until the end of the webinar. Please make sure you have the present list field, and then at the end of the session we are going to have photo session. So now the time to do the closing by director of PHLB ULM. Please, Professor Yudi Firmanur Arifin.
Okay, thank you, Bu Mutia, and also thank you for Peter, Dr. Peter van der Meer from Panhal, Larenstein University. Very nice presentation. Pak Dr. Suryadi, thank you very much for your nice presentation. And also Pak Insinyur Nugroho, MSc, thank you very much also for a nice presentation. I think we have, I think we, next time we can make collaborations, because I think based on your presentation, we have so many kinds of problems with the wetland, especially in peatlands area. And also, this is the challenge for us. How can we increase the valuable of the peatland areas? This is the challenge, very, very challenge for us. And also, so we discuss also about the peatland management. If you often the area in the peatland areas must be careful, I think, because peatland is very fragile ecosystem, and so if we could be will cause the damage if we not attend the characteristic of the peatland areas. So, and also, Peter also said that about the high economic value of peatland area. This is must be considered for I think for improve the quality, the economic value of the peatland, and also yeah. Pak Nugroho also said the concept agroforestry is very suitable, I think, to develop in peatland area. And Pak Riyadi, how can we decrease the fire rate? Yeah, fire rate is very problem normally in the peatland area. So I think this is very nice discussion for today. Hopefully the participant can get the more information, knowledge from the some experts here, and I think we can meet again for the next series of the this webinar. I think because every Wednesday we implement the webinar conference. So thank you very much for all and speaker and also participant and also for moderator to guide us in this conference. Thank you very much, Bu Mitya. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh. Okay, this is directly to close. Okay,
Terima kasih, Pak Yudi.
By say that Alhamdulillah, I close this international conference for today. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you.
Thank you, Professor Yudi Pirmanul Arifin, for the closing. Thank you for the speakers. Thank you for the participant. Again, before we are ending this very interesting webinar, there is several announcements that we would like to share. So the webinar module can be accessed at the following of the website of PHLB. And also, please don't forget to register and to join and to participate in our second webinar in the following week. And for this webinar, also can be accessed via YouTube. So you could share all the thing that happened today through YouTube, through your friend, college, and student. And the last one is we are going to have the series 2 of the webinar that would be held on the 23rd of September, 2020. So please register and ask your colleagues to join and share this information to all of you, your friend, and all your staff and everyone else out there. All right, so we are coming to end of the webinar for today. Please prepare your camera to do photo session. This is the flyer for the next week. Oh, I'm going to be one of speakers then. All right, I hope you are going to join the next series of our webinar of sustainability of wetland webinar. All right, so all the speakers and participants and team and committees, please prepare your camera. We are going to do the photo session. All right. Please, operator, take the session because we have 4 slides of people here. So,
yes.
Smile, 1, 2, 3.
Okay.
Again.
Slide 2.
Another one, 1, 2, 3.
Ya, belum ada yang buka kamera.
Open your camera. All right, 1, 2, 3.
Okay.
Last one. All right. Okay. 1, 2, 3.
Okay.
Okay, thank you very much. Thank you very much for all the speakers, for all the interesting topics that has been
Terima kasih, Bu.
been delivered for today.
Terima kasih, Pak Yudi.
Terima kasih. Jadi, terima kasih Pak.
Terima kasih.
Thank you very much, Pak Yudi.
Sampai ketemu Pak Nugroho.
Yeah.
Next, the second series of the SOW webinar in the next week. I'm as a moderator and MC for today. I would like to say thank you very much for all your kindly attention. I would say sorry if my language has something problem and my internet connection in the previous time. All right, would like to see you in the next week's seminar.
Okay.
Okay.
Bye-bye.
Thank you.
Thank you very much, Ibu.
Bye-bye.
Me too.
Bye-bye.
Thank you.
Thank you
Bye-bye.
very much.
Bye.
Thank you.
Talk later.
Thank you, Pak
Bye.
Peter.
You're welcome, and
Thank
Ibu,
you,
me too.
Yudi.
Thanks for facilitating.
Thank you, Pak Nugroho, Pak Suryadi. Thank you all.
Bye.
Terima kasih Bapak Ibu.
Terima kasih Bu Mutia.
Iya,
Nggih, nanti nggih Bu. Sudah merepotkan. Nggih.
Alhamdulillah.
Bapak Ibu yang lain siap-siap ya Bu, minggu depan Bapak Ibu juga peserta minggu depan salah satu pemateri Bu Mutia.
Insya Allah.
ahli apa nih? Aduh,
nggak ada ahlinya,
lupa saya
belajar.
membran, ahli membran water treatment untuk untuk air asam ya, air gambut ya Bu.
Air gambut.
Nggih, kita belajar. Pak Kissinger, Dekan Fakultas Kehutanan, selamat siang Pak.
Bapak Dekan baru pulang pengukuhan ini.
Iya, kayaknya sambil jalan nih masih digambut kayaknya nih. Kalau ketawa nih kenyang kayaknya nih. Kalau ketawa. Pak Junius Akbar, Pak Budi Sutia, Pak Triyono, Ibu Betty, Pak Irawan, Pak Roni, Pak Edi Gunawan. Mumpung sudah bahasa lokal saya bisa Bu.
Makasih Bu, izin live.
Oh, nggih, monggo Pak Yunius, nggih. Pak Irawan, monggo. Pak Haryanto, monggo. Pak Kuncoro.
Minggu depan.
Nggih, selamat jumpa Ibu Marjena, Profesor Marjena Unmul. Salam untuk teman-teman di Unmul, Bu. Ibu Pak Ivan di Lisdat dan sebagainya. Selamat siang Pak Triyono Unmul. Salam buat teman-teman di Unmul Pak.
Iya Bu, insya Allah nanti disampaikan.
Nggih, so yang ketiga nanti dari Unmul insya Allah Pak, narasumbernya ada satu dari Unmul. Jadi ketiga nanti Pak ya.
Iya Bu, insya Allah berpartisipasi.
Anton ya Bu.
Nggih.
Ya, kita sama-sama membahas COVID se-Kalimantan dengan Pak Anton.
Oh, okay. Sekarang agak menegangkan di Samarinda soal COVID, Bu.
Iya, Pak. Padahal di awalnya sangat bagus, sekarang ya di mana-mana ya itu.
Terlena ya, Bu.
Mohon pamit.
Bu, jenis memang tidak bisa dihindari lagi seluruh dunia. Jadi ya.
Tinggal aja. Imunitas kita aja.
Lihat
Ibu-ibu mohon izin pamit Ibu-ibu.
Iya, terima kasih Mbak Farida dari PLK juga.
Ya.
Pamit Bu Mutia.
Semuanya. Terima
kasih semuanya.
Pamit Bu Hamidah.
Iya, monggo Pak. Terima kasih. Pak Oyong, terima kasih. Tumben anteng Pak Oyong.
Mana Pak Oyong, nggak ada fotonya?
Pak Budi juga anteng. Pak Budi setia.
Pak Damiri dari tadi antengnya.
Oh, tumben. Nggak ada bulu sih Pak, jadi anteng.
Ada kayaknya ikut.
Nggak muncul hari ini.
Nggak, masak.
Oke,
pamit mau johor dulu.
Terima kasih semuanya. Assalamualaikum.
Waalaikumsalam warahmatullahi wabarakatuh.
Pamit Bapak Ibu, permisi. Assalamualaikum warahmatullahi wabarakatuh.